We'll proceed in summation to integral calculus. Okay, long discussion for the summation to integral calculus. Anyway, we will proceed in the vector because this is what the future that we are seeing in terms of vector. No, vector is not the future. The matrix is future. Matrix is nothing but the vector only. I believe we have discussed little about the matrices. What is a matrix? Matrix is nothing but combination of arranging a vector or combination of vectors. Combination of vector is a matrix. Nothing more than that. Okay, what can be described in terms of matrix? If we talk in terms of matrix, okay, so if we talk in terms of matrix, then what is a matrix? Okay, there is nothing beyond a vector. Nothing beyond a vector in the sense that vector is a straight line. Vector is an energy that moves in a straight line. Vector never moves in a curly manner the way we have a equation of a line. Vector moves in a straight line, an energy which has a direction and which has a magnitude. It is also called vector. So if someone has vector, then he can, what is a vector? Vector has one direction. Okay, like if I say this is x-axis and this is y-axis. Okay, in a fashion that I can think like, consider this is x-axis and this is y-axis. Okay, energy is moving toward x-axis and one energy is moving toward y-axis. If they combine at the origin, energy moving toward x-axis, this is origin, and energy moving toward y-axis, this is origin. At this moment, both energy are combining and then they are moving in one direction. This is called vector addition. Like consider energy moving in x-axis has a magnitude of 2, then we can say that energy as 2i, because vector is a combination of energy magnitude and energy direction. Direction is I vector. I is also called unit vector. Unit vector means only direction. So 2I is a energy that is moving around across the x-axis, and 3J is moving along the y-axis. Now resultant, if this is moving like this coming to origin, and this is moving like this coming to the origin, and then it is going in one direction. Okay, this is just added, that's it. What is the resultant vector direction? If it is 2i and it is 3j, they are meeting at the origin. Two energy are, one is going as 2i, one is going as 3j. They are meeting at the origin and they are moving in one direction. The combined vector, combined energy is in moving in one direction, then it is called 2i plus 3j. Just add it, that's it. 2i plus 3j. No, nothing to need to be done. 2i plus 3j. Okay, this is called energy addition. I'm sorry, vector addition. If I have a vector like this and I have a vector like this, if I add these two vectors, resultant vector will be in between it. If this is the one vector, this is another vector, this is the angle it is making with these two. In between some angle, the resultant vector will go through. This is called addition of two vectors. So it will be 2i plus 3j. What is 2i minus 3j? This is called subtraction of two vectors. Okay, 2i minus 3j. If this is 2i, I have to subtract it with 3j. What is subtraction? Understood addition. That if two energy source coming from two different directions, if they get added, then we just need to add it. What about if I have an energy source called 2i plus 3j? There is energy moving like this, that is 2i plus 3j. At the center, it is combining with another energy called 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 5 called 2j. 2i plus 3j is the energy. It is meeting another energy at origin called 2j. Then it will become 2i plus 5j. What is 2i plus 2i minus 3j? If this is 2i and this is 3j, what will be the subtraction? There is nothing called subtraction in mathematics. In mathematics, only has addition. There is no subtraction. So what do you mean? I mean is 2I plus 3j. I'm sorry. 2I minus 3j can be written as 2I plus 3 and in bracket minus j. 2I plus 3 in bracket minus j. Okay, in that fashion it is addition of two vectors. One vector is going along the x-axis and it is 2I. One vector is going along minus j. If this is origin, then this is j vector, y-axis. This is I vector. This is minus I vector. Minus in mathematics means opposite direction. That's it. It is plus only opposite direction. It is plus I, then minus I is opposite direction. If it is plus j, then minus j is opposite direction. Now I have one vector called 2I coming at origin. Another vector as minus 3j or 3 minus j. It is going towards the minus j direction. So if this vector and this vector meets, resultant vector will go like this. Okay, 2I minus 3j is 2I plus 3 minus j, this direction. 2I plus 3j, 2I plus 3j, this direction. One is this direction, one is this. That's it. If people see everything as addition only, there is no separate subtraction in mathematics. Everything is addition only. That's why vector is precious because it talks about direction and just negate it, reverse the direction. That's it. Means wherever I am seeing negative in vector, is it reverse of the positive? Certain it is just reverse of the positive in direction. There is nothing else here. Okay. Now, if I have kind of consider, I have described it earlier also. Consider now. What about if I have a okay? Understood. If this is x-axis, if this is x-axis, then this is y-axis. Okay, there is a point called 0, comma 0, and there is a point here called 2, comma 3. 2, comma 3, 0, comma 0. If I have a line that is passing 0, comma 0 and 2, comma 3, 2, comma 3, what is the equation of the line? Okay, it will be y equal to 3 by 2 into x. That will be the equation of the line. Y equal to 3 by 2 into x. What about the vector notation? Vector notation will be I plus 3 by 2j. Okay, what do you mean? If it is passing through 2, comma 3, if vector is passing through 2, comma 3, it will pass through 1, comma 3 by, I'm sorry, 1, comma 2, 3 by 1, comma, okay, 1, comma 3 by 2. If a vector is passing origin and 2, comma 3, it will also pass from 1, comma 3 by 2. Then vector will be I plus 3 by 2j or 2I plus 3j, anything. Okay, means why these two vectors are same? Because the direction will be same. If someone say I have a vector I plus 3 by 2j, if I just talk about the direction of the vector, then vector by its magnitude is the direction. I plus 3 by 2j by its magnitude, 1 square plus 3 by 2 whole square root is the unit vector. 2I plus 3j by 2 square plus 3 square root, both will be same. Unit vector will be same whatsoever. If I say I want to denote a vector that is passing origin and 2, comma 3, it will be 2I plus 3j. Okay, magnitude of 2I plus 3j, this is the vector. What is the magnitude, power of this vector? Power of this vector is 2 square plus 3 square root. That is exactly the distance between 0, comma 0 to 2, comma 3. If I want to measure the distance, that is distance. Anyway, if I have a straight line, then I can find a vector equation. If I have a straight line, then I can find a vector equation of the straight line. I'm sorry, if I have a straight line, then a vector equation of the straight line I can find 0, comma 0, 2, comma 3, 2I plus 3j. This is a pure vector 2I plus 3j. What about if line is a curved line? You said vector will move in one direction only. But here, if I want to represent a vector along the line, everywhere it will be tangent vector, everywhere. And there are so innumerous number of vector will come into the picture. Every point, how many points are on this line? There are infinite points on this line. Okay, how many points are there on this line? There are infinite points there on this line. If there are infinite points there on this line, at every moment I have a separate vector that talks about the direction of the line. Separate vector. Can you represent so many vectors in one equation? Okay, one vector I understand 2i plus 3j, 5i plus 4j, like that. Can you represent a bunch of vector along a line that is coming along the line in one equation? Then it will come in an algebraic vector that is in terms of x and y. Okay, what is this vector? If consider this line is, if this line is y equal to x square, the equation of line is y equal to x square. There are two vectors here. One vector is called position vector. If this is origin and this is x-axis, then at each point, if I take any point, then I can connect origin and that point. This is typically called position vector of this point. If I connect origin and this point, this is called, if I connect this point, if I connect this point and origin, this is called position vector. So position vector will keep changing from the origin like this. This is position vector. One is called tangential vector. At every point, as per the line direction, position vector is any point, what is the vector connecting that point with the origin. Tangent vector is at any point, what is the vector that represents the direction of the line. This is tangent vector, direction of the line at that moment. Okay, both are two different vectors. If I say what is position vector, then it will be, it is point is x comma y, then xi plus yj, where y equal to x square. Xi plus x square j is the vector that represents the position vector of this line y equal to x square. And it is innumerous. Xi plus x square j vector is innumerous, depend upon the x. You keep changing x, you keep getting different vectors. Or we have proved it that the tangent vector is nothing but derivative of the position vector only. Tangent vector is nothing but derivative of the position vector. If position vector is xi plus x square j, the tangent vector will be dp by dx. Okay, it will be I plus 2xj. Means every moment tangent vector equation is I plus 2xj. Okay, now anyone can see this tangent vector is again coming in formula of the algebra. It is not a straightforward numeric vector. It is called family of vector or set of vector. I plus 2xj. Keep changing x value, we get different vector. This is more in the vector, a normal numeric vector and the set of vectors. Okay, what is third thing? Third thing comes in matrix. So matrix comes into the picture. Matrix is nothing but set of vectors. I have a matrix where the row are two. Row are two. Consider row is 1. I have a matrix. Row is 1 and column is 3. This is typically called 1 by 3, 1 by 3 matrices. 1 by 3, 1 row and 3 columns. There is one vector there which has 3 components. Matrix is nothing but a set of vectors. That's there is a 1 row and 3 columns. There is a 1 vector with 3 components. Makes sense? What is component? If I say xi plus yj, there is a 1 vector which has 2 components, x and y. Okay, in direction of I and j vector, x component and y component. If I say I have a matrix of 1 row and 3 columns, then there is a vector with 3 components. Someone can say I, j and k. Okay, means how we can draw it graphically, or imagine it graphically, or imagine in real life case study. Now we have many times I believe we have demonstrated this. Consider that there is one output, there is one output, and there are three input. Make sense? There are three input. This is input number one. What is input? Consider there are three wires. One copper wire, another copper wire, another copper wire. There are three copper wires. There are three copper wires. Now through copper wire, signal is coming. Copper wires are connected to three antenna and through antenna, electromagnetic signals are coming. Okay. Now these three wires are through a media. Media can be anything, air, water, anything. Through this media, they are connected to one single output. Output is one and input is three. Three input and one output. Okay, output is one, input is three. Now they are passing through one media and then they are connected to the output. They are not connected to the output directly through a wire. They can connect through a wire, but in this wire there is one resistance, capacitance or inductance whatsoever. One load is there that can be understood in this fashion. If this is output, then they are connected to input. Output is connected to all three input and it is connected through a load. There is a inductance, capacitance, resistance, one impedance, load is there. Now if this signal is coming to output, then this signal is getting a one kind of it passing through one kind of impedance. Okay, one kind of reactance, one kind of capacitance or whatsoever. So this signal is passing through one kind of impedance and then it is going to the output channel. Then this is also, it is going to one kind of impedance and then going to the output channel. Altogether I can say there is a air in between, or there is a impedance here. These are, I believe these are, I forgot the terminology. If I remember, I'll tell. Okay, attenuation. So these are the attenuation factor. So this is the input channel number one, and it is passing through one attenuation and going to the output. Input number channel two, passing through one attenuation and going to the output. Input channel number three, first, second, and third, passing through one attenuation and going to the output. Output is combination of input signal multiplied by attenuation plus input signal number 2 multiplied by attenuation number 2 plus input signal 3 and multiplied by attenuation factor and then going to the output. Makes sense? Now I can say output equal to, consider this is x1, x2, x3 and this is y1, output number 1. So y1 equal to x1 into we can say this whatever the attenuation we are saying as weight, load. So I can say x1 into w1 plus x2 into w2 plus x3 into w3. Okay, I can write like this: y1 equal to x1 w1 plus x2 w2 plus x3 w3. Okay, now someone can say, hey, what are you doing? X1 W1 plus X2 W2 plus X3 W2 3. You can write like this as X dot product with a W, X vector dot product with a W vector. Simple. X is a vector. Three input, you can say three component of a vector. Vector is x1I plus x2j plus x3k, where weight is w1I plus w2j plus w3k. Okay, these weight are stored on these are the input signal x1, x2, x3. Then weight w1, w2, w3, it is stored at the output. Output y1, consider this is the first output. Y1 equal to x, that is input vector, dot product with the w vector. Okay, what is your next question? Next question is, consider there are two outputs now, output 1 and output 2. Okay, now I can say instead of saying w, now I can rewrite it as weight 1, weight 2. Okay, okay, I'll talk it again. This is x1, this is x2, and this is x3. There are three signal waiting at x1, x2, x3. Now there are two outputs, now y1 and y2. These three signals, will go to y1. Same these three signal will go to y2. Now y1 has placed three different attenuation at x1, x2, x3, and y2 also is putting another three attenuation with x1, x2, x3, y2. Now how I can write y1? y1 equal to x vector dot product with w1 vector, or y1 vector means weight belonging to y1, x vector dot product with w, that is attenuation w, y1 vector, y2 equal to x vector dot product with w, y2 vector. Okay, means there are two. Now consider that there are multiple input here. The input I said x1, x2, x3. That is understandable. That is the one signal is coming every minute. In 1 minute, three signal will arrive and they will get multiplied like this and they will produce y1 and y2. After 1 minute, three signals are coming again and they will again be multiplied with the wy1 and wy2 vector dot product and to generate y1, y2. It keep on happening. Consider five samples we have taken. Now we have, someone would say, "Boss, my mind is spinning now. You have so many things. Can you write in a fashion? Then it will come to matrix. Matrix is nothing but simplification of the vector only. Okay, if I have one output with three weight vector and then three input vector, I can write in a matrix now. Matrix with one row. Row corresponds to the output. Row corresponds to y1, that is the first output. There is one output, then one row. Column corresponds to the weights. So that is the weight vector. This is output vector. Y1 is the output vector. Output vector. If I say output vector, right now I have only one output. So this is the output vector. We will talk about output vector. This is the output vector, that is row. And column is called weight vector. Okay. And then input vector is another matrix. So I have one matrix. Input vector is another matrix. If I take transpose input, all matrices are arranged in a row and column manner. I have input vector and that has column as its component x1, x2, x3. One input vector, one row means first input vector. One row, one row of there are two matrices now. One is called output matrix and one is called input matrix, or input matrix and output matrix. Input matrix and output matrix. Input matrix is divided with the sampling. First sample of input is coming. In first sample of input is coming, then it has three orthogonal, three components, I, j, and k, x1, x2, x3. And in output, we have outputs y1, y2, y3. Against each output, I have a weight vector. Here the samples of the input is coming. Against each sample, we have an input vector. Now I take the input vector right hand side and output vector left hand side. Okay, input vector right hand side, output vector left hand side. I do transpose of the input vector. If I do transpose, then I have three columns, three rows now, one column, three row. Each column is belongs to a sampling we are doing. First sampling we are doing that has an input vector x1i plus x2j plus x3k. And now we have output matrix. Each row is one output. There is only one row right now and it has a weight vector. Now if I want output of the first, that is y1, then it is matrix multiplication. Matrix multiplication. That will be nothing but if I have a matrix of one row and three column and another is three row, one column, it will generate exactly one output, 1 into 3 into 3 into 1, 1 into 1. Now this is matrix multiplication. Do you mean that matrix multiplication is dot product of two vectors? Certainly. Matrix multiplication is dot product of two vectors only. It is nothing more than that. So if I have a weight vector, each weight vector, if I have so many outputs, against each output, now we show two outputs, y1 and y2, two rows. Against each row, I have a weight vector, weight vector, weight vector. First weight vector is weight y1, weight of the y1. Another is weight of the y2. Now weight of the y1 will go and it will do dot product with the x1, x2, x3 to generate the y1 data. Now there is another weight of the y2. It will do dot product with x1, x2, x3 and it will generate another output y2. Means I have now, if I see all together, I have three kinds of vector. One is called output vector. That is y1i plus y2j. Output vector has two components. Now if there are two outputs, y1 and y2. Okay. With each y, we have a weight vector. Weight of y1, weight of y2. That is another vector. And then with each sampling of the input, I have input vector. x1i plus x2j plus x3k. Okay, now I have input vector in matrix, input vector at different sampling in a matrix, and then output vector with different row of the output and with the weight vector. If I do dot product, I get the different. So if I do dot product of the weight vector and output vector comes in a matrix with the sampling vector, okay, with the sampling, how many sample you are taking for the input side. Sampling, how many? Is it only one sample we did? One sample against the input vector. So input vector, output vector and weight vector. There are three vectors. If I do dot product of weight vector and input vector per output, then I get the output vector. So the dot, so if I have input vector, if I have input signal, and then it is passing through the attenuation, weight attenuation, then it generates output vector. Output vector and input vector may not be of the same size, not required. Output can be only 2, whereas input can be 3, input can be 4. Okay, so input vector dot product with the weight vector will generate another shape of vector that is called output vector. Now more complexity is input, weight and all are algebraic vector. Okay, this is one thing. If I have a matrix and if I try to calculate the value of the matrix determinant, then it will be cross product, that is dot product and between intra matrix multiplication. Intra matrix multiplication is dot product. I'm sorry, intermatrix, between two matrices. If I multiply two matrices, then it is called dot product of the vector that is stored in the matrices. There is an intermatrix multiplication. Inside a matrix, we do multiplication. That is called cross product. As the way we do the cross of the, to calculate the determinant value of the matrix. Value of the matrix is nothing but cross product of all the vector. If I have a two vector, I have a two vector. One vector, I have a 2 by 2 vector, two output rows and two weight vector. Okay, if I calculate the determinant, it will be cross product of two weight vectors. One means weight vectors are there in two numbers. One weight vector corresponding to the one output, another weight vector corresponding to another vector. If I want to do cross product of these two vectors, arrange in a packed manner in a matrix and calculate the determinant. Same thing will be 2 by 3, 3 by 3 matrices. All are cross product only. Anyway, so these are the vector terminology. We will proceed in our summation to integral, the concept that we are focusing into. Summation to integral. Okay, this is the area. This is the area in which we are proceeding the discussion. Summation to integral. And in summation to integral, we calculated the tangent in the previous session or in the past session. If this is a circle, we are trying to calculate the circumference of the circle. To get the circumference of the circle, we have x-axis. If I have x-axis, then this is y-axis. X-axis, y-axis. Now I chop this x-axis into n different parts. N different parts. If this axis is of radius a, if this axis is of radius a, then this is minus a, this is plus a, and this is origin. Each section is of width. Each section is of width is 2a by n. Now consider this is the ith section. If ith section goes up and hit here, then what is the length of this section? Say pi, perimeter of the ith section. Then what is the length of the circumference? Actually, it will be from here to here only because we are taking x-axis and we are mapping only in one direction. Summation, sigma sign, summation I equal to 1 to n parameter of the ith section. This is parameter of the ith section that falls in the ith section on the x-axis. If I take all the section on the x-axis which is at equi width, same width, but if it goes map on the circumference width will not be the same. It will vary. Here it is big circumference will come, and here less width of circumference will come. Okay, so now we have summation I equal to 1 to n perimeter of the I is the length of the ith section. If I sum for all, I get the circumference, half circumference I'll get in this manner. Okay, then we saw that how to find, one way we talked about that if this is the ith section, if this is the ith section on x-axis, if it goes up, then it hits 2 point here. One from origin, if I take this point, this is position vector P1 and this is P2. If I do P2 minus P1, then it results in another vector. This is P2 minus P1. P2 minus P1. P2 minus P1. This is x1 comma y1. This is x2 comma y2. Okay, P2 minus P1 will be another vector. If I calculate the length of this vector, more or less I can consider it is same as the circumference, but it will not be the same. If I want the same, then n section we have divided n tends to 0, infinity. If n tends to infinity, then this section will be very small and this curve length and straight line length will be same. This is approximation that we have done. Now we are talking about accurate result. To get the accurate result, we will not do any approximation. That I have one vector like this, and this is the length of the vector, and length of the vector is same as the circumference of the vector. Okay, in that fashion, if I have ith section, then if I measure the length of the vector and add all the vector in that fashion, I will get the circumference. This is called estimation. Another criteria that we took is tangent technology. Tangent technology is at if I take any point here, if I take any point and consider this point is x comma y, this is x and this vertical is y, this is origin, this is x, this is y, this point is x comma y. What is the tangent vector at point x comma y? Everywhere tangent vector is different. This point, the tangent vector, if we talk about, the tangent vector will be vector representation of a tangent line. If I talk about tangent line at any point, then at this point, whatever point we are taking at this point, take a small, this point, it is going x-axis here and it is going y-axis here. On x-axis, take a delta x region, delta x. Means this point is x, then take one more point x plus delta x. Means I am taking a small, very small region here, or momentarily region, say x only. Okay, at this point, I'm trying to find the slope of this point. If this is the point on the curve, then what will be slope? Slope means it makes angle with the x-axis, tan theta of that angle. That is called slope, y by x. If I take calculate slope, everywhere slope is different. If you see here, slope is 90 degree. If you see slope is 0 degree. Slope is different. At any moment, if I want to calculate the slope, at that moment, I take, this is the line. This line, if I take small region of the line around that point, then that line will have x-axis, that line will have y-axis. This y-axis, I say delta y, and x-axis, I believe it is understandable. If I am taking any point here, where I want to calculate the line equation which is tangent, okay, then at that point, I take a small region here. This small region has a vertical and horizontal. Vertical is described as delta y and horizontal is described as delta x. Delta y by delta x will give this line. If I draw a line here, that line angle with the x-axis tan theta, that is delta y by delta x. Okay, then we came to know that then what is the equation of that line? Y equal to delta y by delta x at a particular x into x. Y equal to mx is the line equation of a straight line. then it becomes y equal to delta y by delta x at any point x equal to x1 alpha whatsoever into x. What is the vector representation of that line? That is vector representation. What is delta y by delta x? Change in delta y when there is delta x change along x axis. If I talk about any point here, if I take any point here x, it go hits on the x axis at x. If I move little bit on the x called delta x, then I have 2 points here. One is x plus delta x. If it is goes up, it matches like this, x and x plus delta x. Okay, between x touch and x plus delta x touch, there is a delta y. Means I'm trying to say if I move delta at any point x, if I move delta x, then at that point if there is a y, then y will move delta y. Per delta x, how much you are moving in y delta y. Per delta x, how much you are moving in y delta y. Then per unit on x, how much you will move delta y by delta x. Per unit in x, how much you will move in y. Per delta x, how much you are moving in y delta y. Per unit, 1 unit in x, how much you will move delta y by delta x. Okay, means I have to calculate a vector that is passing through origin and point 1 and delta y by delta x. Means if I'm trying to find the vector equation at point tangent, if I take any point here, what is the tangent vector equation? If I want to calculate tangent vector equation, then tangent vector equation, if this is delta x, then this is delta y. This is the point. Okay, this is the point. Consider that what is the vector equation of what is the vector equation? Vector passing through origin and point 2 comma 3, 2i plus 3j. Okay, is there any other way? Other way is it is same as I1, the line that is passing 2 comma 3, same line will pass through 1 comma 3 by 2, 1 comma y by x, same line will pass, same line. If there is a line that is passing 0 and 2 comma 3, that line will also pass 1 comma 3 by 2, 1 comma y by x, 1 comma delta y by delta x. This is important because we are calculating delta y by delta x momentarily. Every moment what is delta y by, because delta y by delta x, every moment will change. If I take at any moment delta y by delta x, then vector representation I can think at delta y by delta x is the vertical where horizontal is 1 unit. If horizontal is delta x unit, if horizontal is delta x unit, then vertical is delta y unit. If horizontal is 1 unit, then vertical is delta y by delta x unit. I have a vector, I have to find a vector representation that passes through x as 1 and y as delta y by delta x. Then it will become I plus delta y by delta xj. That is called tangent vector. At any moment, what is the tangent vector? Any moment tangent vector is delta y by delta x. This is extremely important. This is called point vector. Point vectors are extremely, if I was saying earlier that I am dividing this x axis into n different chop. If I take ith section go and hit here. Here width is delta xi. It goes and hit here. That is, this width is pi, perimeter of the ith section. Okay, if this is position vector P1 and this is position vector P2, then P2 minus P1 is delta P. Delta P is big. Delta P is big, which correspond to 2 points. If I have 1 point, if I have another point, there is a vector that will pass through these 2 points. I am saying delta P, P2 minus P1. This is P2 vector, this is P1 vector. P2 vector and P1 vector, if I take, it will go on x-axis and it will hit the ith section if I divide it into n section. Ith section width is delta x, it will go and hit here. There are 2 points here, and at 2 points the connecting vector is delta p or P2 minus P1. If I get the delta p length, then if I add all, I get more or less the circumference of the circle, provided n tends to infinity. But what we are talking now, the tangent vector, it is called moment vector. Every moment tangent vector is different. It does not correspond to 2 points. Earlier, what we calculated, what is the length of the circumference? Summation I equal to 1 to n delta p belongs to the ith section. If you add all the delta p value, you get the circumference. This is different concept where every moment, if this point is x comma y, means point 0, point 1 is point 1 comma whatever the y is. Then there is another point. If this is origin, consider this is origin. This point is point 1 comma whatever the y is. There is another point called point 11 and whatever the y is. There is another point called point 110001. Then at, there are infinite points on this circle. And every point has different tangent vector depend upon I plus dy by dxj. Okay, we can say the tangent vector is derivative of p. If there is a position vector p and xi plus yj, if I calculate derivative, it is again I plus dy by dxj. Means tangent at every moment tangent vector is different. If I calculate magnitude of the tangent vector, then it will give the length of this line. If I have a vector that connects 0, 0 and point x comma y, that is xi plus yj, if I calculate the magnitude of that vector, that will give the length of this section from 0, 0 and x and y. Similarly, if I have a momentarily vector as I plus dy by dxj, if I calculate magnitude of this vector, it will give the moment at that moment what is the length of this arc. That will be very small. Okay, now I can say that if there is a 1 unit of length, if there is a 1 unit of x brings that much vector length, then how much vector length, curve length, then how much curve length I can expect with delta xi. Then it is summation I equal to 1 to n and then curve length, momentarily curve length, that curve length belongs to 1 unit in x, that is a square root of 1 square plus dy by dx whole square. The vector is I plus delta y by delta x dy by dx. If 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 x tends to 0, means n number of section we are making is infinite or whatsoever. If delta x tends to 0, then delta y by delta x is dy by dx. The momentarily tangent vector is I plus dy by dxj. Its magnitude is 1 plus dy by dx whole square root. This magnitude is per unit in x. If x is delta xi, then multiply by delta xi. This is one philosophy of calculating the circumference. Again, summation I equal to 1 to n, square root of 1 plus dy by dx whole square into delta xi. This first section is the length of the circumference per unit in x into how many unit in x you want. If you multiply, you will get for that unit of x, that is delta xi, you will get the full curve length. Okay, that is 1 plus dy by dx whole square root into delta xi. And then summation I equal to 1 to n, where n tends to infinity. This is one philosophy. Now, there is another philosophy. What is another philosophy? Okay, what is your tangent vector? Tangent vector is dp by d. Luckily, I did not know the tangent vector at any point. At any point here, if I draw a line from the origin, then position vector is xi plus yj. If this point is x comma y, then tangent vector is I plus dy by dxj. Luckily, it is tangent vector is derivative of position vector. If I calculate derivative of any position vector, then it will result into another vector which will be tangent at that point. It may be perpendicular to it, may not, but certainly it will be tangent at that point. If I have position vector, any position vector, if I have a parabola, this is x-axis, this is origin, and this is position vector of any point. If I calculate derivative of this position vector, it will become tangent vector at that point. Everywhere position vector derivative will become tangent vector. Okay, now tangent vector magnitude, if I calculate the momentarily length it will give at that moment, because tangent vector is based on the point constant. Every point tangent vector is different. If I calculate magnitude of tangent vector, then it momentarily length it will give. Okay, is it the length actually? Certainly not. That is called velocity vector. If there is a, what is p? P is the length vector. The p, if I talk, that if I position vector, if I talk, if this is a position vector, this is another position vector. If I have something, if I have a measurement in meter, there is another measurement in meter. If I subtract or add, the net resultant will be meter only. Meter plus meter is meter. Meter minus meter is meter. Similarly, if I say I have P2 and I have P1 vector, if I subtract P2 minus P1 will be this vector. This vector is nothing but a length vector only. Means position vector is length vector. Okay, if position vector is length vector, then dp by dx, that is derivative of position vector. If position vector is xi plus yj, dp by dx will not be the position vector, it is velocity vector. If I calculate, if I have p2 minus p1, p2 vector, p1 vector, p2 minus p1 is this vector. If I calculate magnitude of p2 minus p1, that is delta p, it will give magnitude more or less similar to this. Consider this is dp by dx at point x1. This is dp by dx again derivative at point x2. If I do subtraction of these two, will it give the length? Subtraction of dp by dx at point x1 minus dp by dx at point x2. If I subtract this, it will result in another vector. dp by dx is a vector. dp by dx is another vector at point x1 at point x2. If I subtract, it will result in another vector. If I do, then will it give, this is dp by dx, this is dp by dx vector, tangent. This is dp by dx vector. If I subtract these two vectors, then will it give this vector? Certainly not. This is called velocity vector. This is different vector. If position vector is the meter vector, length vector, then dp by dx is called velocity vector. If I subtract two position vector, it will give displacement. If I subtract dp by dx to dp by dx, it will give velocity, not displacement. Both are two different things. So if I am saying I am to get the length, dp by dx magnitude into delta xi, more or less we are converting this velocity vector to displacement vector. If x is time, then dp by dx is velocity. X is time, then distance by time is velocity. If I multiply by delta x, dp by dx, if I multiply by delta x, then meter by second into second, it will come to meter only. Means this is leading to something different arena, and this is called velocity vector. There is a new arena that is seen now, and it is called velocity vector. Velocity vector has different graph. Now consider, this is the x-axis, time axis, and this is velocity vector axis. This is x-axis, then this is dp by dx. If this is x-axis, then this is dp by dx. Now at different x, we have different dp by dx. Means if I have a circle, and this is x-axis, then dp by dx is different at different x. Now make a chart. If this is x-axis, then vertical is dp by dx. Against each axis, I have a dp by dx vector or its magnitude. dp by dx magnitude. If I calculate magnitude of dp by dx, it will give one number. At different x, I have different dp by dx. Someone can draw a graph like this. Okay, this is called velocity graph. Velocity at every different x, I have every different dp by dx. Different dp by dx. What do you mean? If I calculate integration of this is the dp by dx, but that is the vertical dp by dx at different x. If I do the integration of it, it will give the area. It will give the area. What do you mean? If I do integration of velocity with the time, it will give the distance. If I do derivative, calculate derivative of distance, it will give the velocity. Means if I have momentarily velocity, if this is the x, then at that time this height is the velocity. If this is the x, this height is the velocity, and this is a continuous function because x can be infinite. In that sense, velocity are infinite. If I calculate the area underneath, I get the actual distance. This velocity dp by dx, if I calculate what is the velocity, dp by dx correspond to the velocity that is along the curve. At every moment, velocity vector is different. Every moment, that is a tangent vector. Means if I calculate integration of dp by dx along x-axis, then it will be distance, and the distance will be exactly the curve distance. Exactly. What do you mean? dp by dx into dx from x begin to n. That will give the exact. So what we are saying, summation I equal to 1 to n tends to infinity. dp by dx is magnitude into delta xi. This is same as x1 from begin to n dp by dx through the normal velocity vector calculation. And that means this approach is more concrete and more fine approach in proceeding with the repeated summation to integral calculus. Now we have dp by dx, that is a velocity vector at each point. If you calculate its magnitude, you get the magnitude, but it is a velocity. Multiply with the delta xi, you will give the net curve length exactly, and then do the summation. Now it is same as summation integration minus a to a dp by dx magnitude dx. Someone does, he will get the circumference, multiply by 2 full circumference. This is called velocity. Understood, understood, understood. You are doing something different. Okay. Then can you calculate the area by the repeated summation, and then your velocity vector and acceleration vector, and these and that we will do. Okay, one more session I believe, where we do this fundamental. Indeed, we will try to calculate area. Okay, area can be calculated through the dp by dx. Okay, tangent vector. Can we use tangent vector concept? The tangent vector concept, we calculate the length of this line very smoothly. No need to go for any estimation at all. Can we use this tangent line concept to calculate the area, calculate the volume, where it will be very accurate? No need to do any. If you read any book to go for any calculation, people start doing like this. This is delta x, this is delta y, this is delta z. Consider it tends to 0, consider tends to this, consider tends to that. Nothing is required. Can I use concept of tangent vector in calculating the area, calculating the volume? Okay, I mean, we will say. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone.